last name is pronounced Weyl.
Hi, everybody far away and in the office. I'm Harold Kirshner. I work on Quantum for a year now, trying to figure out metrics that matter to optimize against and to get performance back into the culture of Mozilla for everybody to be proud of to talk about performance and how fast Firefox is. And yeah, looking at November and what we're releasing, I think we got really close and everybody is proud of what we did. So here now we have Estelle Weyl to talk about performance and why it matters to us. So it matters to platform to optimize the things that really matter to the web and making all websites fast. And it matters to our front-end engineers that make Firefox UI to make the things look snappy that people use every day in the browser. And it matters to web devs at Mozilla to make the websites that people see as a first impression of Firefox fast. So Estelle worked in performance at Insert Logic, where they actually applied science on performance and how users perceive it. So hopefully we can learn a few things from them. And if you want to talk more about performance, ping me later, come to the stage or chat for in Slack. With that, take them to Estelle.
Thank you. Hi, so I'm actually doing this talk in the nightly build. So if we have any quirks, it's your fault and not mine. But the slides will be up at, my name is Estelle, and there aren't that many engineers named Estelle. There's actually one other one, and it's terrible because I keep getting all of her PRs, or pull requests. But my name is Estelle, so just remember Estelle, github.io or github.com/Estelle, and you'll find all of my talks, and this one will be there as well. I'll put a link up to it. I'll put a link up to it later on. So today we're going to talk about, I'm going to give a performance overview, and then I'm going to talk about two visual metrics, speed index and perceptual speed index. And then I'm going to talk about a study that we did measuring the navigation timing API metrics and speed index to see which metrics best reflected what a user's perceived, what they perceived, the performance that they perceived. Because metrics are in the computer and we can measure them, but it's really what the human is seeing, what the user experience is that's important. And which metric best reflects that is what we were looking for. So my name is Estelle Weyl. I'm an open web evangelist, and I'm a front-end engineer. And I'm fun employed, so if you know of any good roles, I hear there's a few here. Maybe I'll try it out. I write books. If you ever have insomnia, this is a great collection to add to your bookshelf. And the CSS, the Definitive Guide, is coming out in a few months. So it's 1,174 pages. And it doesn't even cover all the specs, but it covers almost all the specs. So that's exciting. So first part is the performance overview. Oops, I'm in the wrong deck. Hold on one second. OK, so if I say something loads in 2 seconds, is that fast or not? 2 seconds is not fast? Do you know that the average web time for a page to load is between 6 and 14 seconds? So for a hello world, it's not fast. So if you think 2 seconds is not fast, what about 18 seconds? Is that fast? No. If you were downloading the Lord of the Rings trilogy, would 18 seconds be fast? Yeah. OK. So really, what does fast mean? Fast means different things to different people, and you can't really pinpoint one measurement, because someone said mobile, like 2 seconds would be fast if it's on mobile, but it has to be under 1 second if it's on desktop. Good luck reaching both of those metrics. But when you measure something, when you're measuring a website, every time you measure it with the API metrics, you're going to get different numbers, because the network differences make a difference. The computer on here make a difference. Whether it's hot or cold even makes a difference. So, you know, what you really want to see is what your average is, but you don't want to, you also want to see what's happening on the long end, on that tail, and is that something that a whole population is getting, or is that caused by a single issue? So what is load time? It's different things to different people, and it's different things at different times of day, and it's different every time you measure it. So I'm going to ask you which feels faster. I'm going to play both of these videos, and they're both going to load. And let me know which one you think loaded faster. So did the one on the right or the one on the left load faster? It actually hasn't finished loading. Right? But the thing is, you all thought it had loaded. So our metric of load time would say that the one that you thought felt faster was actually slower. So is load time, or visually complete, because that's actually visually complete, is that a good measure? So what is performance? Performance is many things. It's time to load, which is what we were just looking at. It's time until it's usable, because those sites might not have been usable until it finished loading, or it might actually have a DOM content loaded that takes like several seconds while it's parsing and executing the JavaScript. There's jitter that makes sites feel like they're slow. There's responsiveness when you're touching it. Does it actually react to you? And then there's the smoothness of scrolling. So all of these things are part of performance, but not necessarily caught by those metrics. So Google came out with the Rail narrative back in 2015, actually. And Rail is kind of a misnomer. It's actually liar, because if you look at the colors, it actually goes from load to idle to animation to response, if you look at the bar, as to what the process is for a page load. But there's certain things you want. You want the page load to load in a second or less. And that is a goal, and that's what we're all aiming for, but we're not there yet. And it's okay that we're not there yet, but that's something we want to work towards. You want an idle time of 50 milliseconds or less, because if you're running JavaScript, the browser is single-threaded. So if you're running JavaScript and you're occupying the UI thread and someone clicks on a button, they won't actually see a reaction if you have a long-running script. So you want to basically run your JavaScript in snippets that take less than 50 milliseconds. In terms of animation and scrolling, you want to execute all of the JavaScript that you have to do and allow for time to repaint the page in 16 milliseconds, because you want 60 frames per second. So 1,000 milliseconds divided by 60 is 16.67. And a response to input, you want the user, when they click on a button, to know that something happened right away. If it takes more than 200 milliseconds, they'll actually think your website's not working. So the goal there is under 100 milliseconds. So that's the Rail rules. So web performance, measuring how long a page takes to load and how perform a website includes the downloading of all the resources. So that has to do with like how many bytes you're downloading. The parsing of those files, the execution of the JavaScript and the painting, and then the perceived performance, which is the user's perception of how fast that page is going. So there's a navigation tabbing API, and it has a bunch of metrics. I'm not going to go over them. I just wanted to show you that there's like, you can measure navigation start, you can measure domain lookup end, you can measure response end, you can measure DOM loading and DOM interactive. These are all things you can do with JavaScript. But the thing is, these are objective metrics. These are things that that the computer can tell you, but they're not reflective of what the user is seeing. So we have all these objective measurements, but a user's perception is really subjective. And how do we figure out some objective measurements to measure that subjective loading? What is the best objective measure? So I'm going to play these two videos. They have the same load time of approximately 3.7 seconds, right? So they should be equal. But their visually complete is very different. So we have two metrics that are measuring the same, like these are two metrics measuring the exact same website. And one is saying that the load time was 3.7 seconds, equal on both, but the visually complete is twice as long, or almost twice as long on one. But did it feel like it took twice as long to load? Not really. It depends. It actually depends on different users. Some people will think that the last thing that came in was this little piece up here. And does that impact a user? Do they care? We don't know. That's something we need to study. No one's really studied it before. So I'm just going to show you this a different way of comparing it. And when I said that page load time varies between different times you load the page, you just saw the video, right, where it was 3.7 seconds and then 6, 8, and so I used web page test again, and I came up with different numbers. But what I want to show you, it doesn't really matter what numbers I came up with. It's, if I can scroll here, it's the fact that when we were looking at last change, staples took much longer, right? But if we look at visually complete, staples was much faster. So what's the perfect metric? So I always used to use this expression, statistics lie and liars use statistics. And I thought it was someone else's quote. And then I went to look it up and I couldn't find it on Google. I'm like, so it's my quote. And I made it up like 20 years ago when I was actually taking biostatistics for health reasons. Like I was a public health major, not in performance. But you could basically prove anything. So if your boss says, make this faster, I want to be faster. Like if Staples says, I want to be faster than Wolferman's, they'll just use visually complete instead of last change. And they can say, we are, you know? And so web development, you know, but basically the important thing is, what is good user experience? Which one of those metrics measures that? So what is good user experience? So which one of these two sites, this is the BS load of the page, it's not real, but which one loads faster? The one above or the one below? It depends. So people will actually feel that the one above loads much faster than the one below. Because when nothing is happening, people think your site's not working, and they notice it. If it's loading and there's progress, they're more willing to wait. So you want to achieve the results above over the ones below. Like if you had to make a choice between how you're going to load your site and these were your two options, a slower load time would be better. And then the thing is, once the page loads, let's say you make it load really quickly, and then you do this. Let me see if I can do this. Yeah. You see that pink line? That is a 2.5 second, 3 second DOM content loaded event. So that's 3 seconds where the page looks like it's loaded, but you can't interact with the page. So then a user would think that your site is broken. So when we were doing the study, and when we're thinking about perceived performance, you have to think about, like, these are different things. Does jitter impact a user's perceived performance? On that Staples site, when those little things came in and the carousel started moving, at what point did people think that the page had already loaded and they didn't care that there was jitter? Or does that jitter really bother them? Do modals impact perceived performance? If someone has a modal, do they feel like the website has gone slower or faster? Does a DOM content loaded event, that 2 second, does that really make a difference? These are things that I thought made a difference, but I don't know. And so we have all these objective measurements, and we haven't studied these subjective things of what is annoying, basically. But the thing to remember, no matter what you're actually working on, is that the user experience always outweighs the developer experience. So I see a lot of developers doing what I call RDD, or resume-driven development, where they stick in every single framework because it makes life easy for them. But then it makes that's what caused that 3 second DOM content loaded event. That was the parsing and execution of 41 dependencies. You know, it was quick to develop the site. It was easy. People didn't need to learn the underlying markup, but it was not good user experience. So I want to talk about two visual metrics, speed index and a related metric called perceptual speed index. So speed index was developed by Pat Meehan, who runs web page test and works at Google. It's basically the quality of experience of above the fold performance. So this is, I believe it's Wolferman's and Staples. Yeah, you don't have to see the little, I realize this is really small. There's no details that you actually have to see. But one of these, the blue one, is Wolferman's loading, and the pink one is Staples, I believe. Blue is Staples, pink is Wolferman's. So the area that I highlighted in pink and blue, and I'm going to cover it in a minute, so don't worry if you can't see the screen, is how you measure speed index. So speed index, this is the equation. And can anyone read that equation? Do you want to explain it to us? Okay. I'm not going to explain it to you. I'm going to show you how it works. So basically, web page test, to figure out speed index, takes a screenshot, a virtual screenshot, every 100 milliseconds. So there's 10 screenshots per second. And then it calculates the last screenshot and the first screenshot, looks at the difference, and it says what percentage loaded is this? How many pixels have color on it, basically? That's not exactly how it works, but that's the general idea. So if there's nothing loaded in the first second, right, you get 1,000 points, or 1,000 milliseconds, because you have 0%, which is 100, 0%, 0%, that's 100. So in the next second, like at the 1 second mark, let's say it fills up at 50%, and it's half drawn, right? So you get 50, 50, 50, 50 times 10. So you're at 1,500 already for speed index. And then here, half of it was still, during 500 milliseconds, it was still only at 50% complete. So that's 250 milliseconds added there, 5 times 50. And then it went up to 40%. So 40% not complete yet, or 60% complete, is 40 times 5, which is 200. So here, your speed index at this point is 1950, and then you get a little bit more, and a little bit more, and this is the page loading up. So it's the empty space that we saw on top of that loading graph, filled in every 10 seconds, what percentage is still left to paint. And that's how speed index, and that's what this crazy looking equation basically measures. It goes from the time that the request was made to visually complete. But you notice that we all thought the page had loaded before visually complete. So it's a frame by frame progress. It's a pixel histogram. Well, I'm not going to. The thing is with speed index is it basically measures, was the pixel on the page, like was the pixel drawn on the page or was it blank? Comparing it to at the end, how many pixels are drawn on the page and how many are blank, because you still have white space. So that's what it's measuring, the difference between those. The thing is, that doesn't measure jitter. So it doesn't really reflect whether there's shape or color or object similarity. So I'm going to show you by example, if the page loaded at 0 seconds, it showed like this, and then it was inverted, it would have a speed index of 0 because it has 50% of the pixels are colored. And here, the difference between like the mean histogram difference is also 0. In all of these, it's 0. So if you were to flip, like if the page were to load and move to any other one of these, it would have a speed index of 0. And then I'm going to let you do this for a second. If you take your finger and look at this. See how the top and the bottom look the same? So the pixel-wise similarity doesn't capture color similarity. And then it doesn't measure, so sometimes you'll load, like an image loads, right? And it loads really fuzzy and then it comes into focus. That speed index would be 0 on that change because there's pixels there, even though it's a very different picture. So if you look at the picture of Einstein here, this to us is the best one, right? The mean histogram difference is 144 there, but the similarity index is 98. Whereas here, or here, the mean histogram difference is the exact same at 144, but the similarity is at just a little under 70%. So you want to measure that too. So that's where perceptual speed index came in. And so it was just using SSIM instead of just mean histogram difference. So these two numbers are actually the PSI that measures it versus using similarity is very similar. So if you have this video and it loads, you'll see there's no jitter almost, and the two numbers are, the SI and the PSI are the same. These were taken in 2015, so the sites are slightly different now, but Etsy is known for its performance, and it doesn't have any jitter. And this one does have jitter at the 13-second mark. So I'm sorry that this takes a while to load, but you see pages don't load in less than 2 seconds. And it's just a carousel changing. So if jitter affects people's perceived performance, then perception of performance, then it makes a difference. But maybe people don't care about jitter. But they are linearly correlated. So PSI and SI are very similar, but one actually is able to take jitter into account. So they're linearly correlated. When there's layout thrashing, PSI will be a much bigger number than SI. And SSIM is known to be a better reflection of human perception, as you could tell with those pictures of Einstein, right? So looking back at Staples and Wolferman's, yeah, this is Staples. It's not that much, I mean, they're correlated, but the SI will be much lower. And with Wolferman's, the PSI is much lower. Okay, because Staples had all that jitter, right? So PSI gave you a bigger number. So basically, to summarize, speed index, they're both focused on above the page load, with PSI accounting for jitter. They're not competing algorithms. They're actually very complementary. It's just one measures jitter and the other one doesn't. So these are resources on both those products. Speed index is in a web page test, and perceptual speed index is actually the number that is used in Lighthouse. And there's an article about it, and the GitHub. This is all open source. Okay, so speed perception was a study that we did. So let me cover that. And it measured those along with all the other metrics. So speed perception was a large-scale web performance crowdsourced study focused on the perceived loading performance of above the fold content. What did it look like? Well, this page doesn't load. So I opened it up here. And it was basically, you hit start, and this is the next version of it, but not the original version. And this we didn't do, so we didn't measure how long it took people to actually click. But what we did do is we showed them 2 videos of pages loading, and then all you had to do was say, did the right one or the left one load faster? I'm going to go with left. And then you were provided with 20 videos. So this is what I just showed you is the second version. So the second version includes mobile, and it includes actually grabbing times of people's reaction time, and it also includes demographics. Because I have a theory that the older you are, the longer you've been online, the more likely you are to wait actually a little bit longer for web pages to load. I could be totally wrong, but I want to study it. That's my hypothesis for study number 2. Okay, so we had 3 hypotheses. One was that visual metrics would perform better than non-visual metrics, right? That made sense because you're looking at a website. That no single metric could explain human choices with 90% or better accuracy. So there was no actual metric, visual or non-visual, like subjective or, well, they're all objective because they're all measurements. And the third one was that the users would not wait until visually complete to make their choice, despite the fact that the instructions explicitly told them to wait until it had turned gray. Because remember when we did that first one and you all said which one was loaded faster, and you knew which one loaded faster, and it's like, well, it's not done yet. So we had 5,444 sessions, of which 51 were complete and valid. So what that meant was that people did all 20, and there were 3 honeypots in there that we knew one was definitely faster than the other one. They were allowed to get 1 of those wrong, but if they got 2 or 3 of those wrong, their results were thrown out because they were not paying attention. Out of those that created for us 77,000, almost 7,500 votes, of which 75% were valid. And if you look at the distribution, these are the pairs. All of them got between 230 and 350. So this was a robust study. Like, we were amazed at the fact that this many people sat through that and did the game. We also had a comment section. And this is what led to study number 2, which is like, there's so many pop-ups. So the first study was done on retail sites, so e-commerce sites, the top 500 e-tail sites. The next study is done on those plus Alexa 1000, so you will get sites that don't have pop-ups, because e-commerce sites tend to ask you to register for their mail list before they even tell you what they're selling. Okay, so I'm going to start with hypothesis 3 because it's going to impact the other two. So hypothesis 3 was users will not wait until visually complete to make their choice, in spite of being told to wait. And that came out to be true. So visually complete is right here. These numbers are not, like, they look like they're equidistant. They're just inline in terms of what order they happen in. But basically it happens sometime after load time and before visually complete. That people, some people way before load time. There's different times, but it's definitely people do not wait until visually complete. So that will impact, the reason I went with 3 first is because it's going to impact the response to hypothesis 2. So hypothesis 1 was visual metrics will perform better than non-visual metrics. And so what I did is I striped the visual metrics so that you could see the difference. And you can't really see the fact that I striped them. But that actually turned out to be not true, because visually complete had a 16% correlation. And you'd think that's what that's the measure that people use. And load time, which is not a visual, because it's actually when it loaded, was much more relevant at 50% or 52%. First paint was 58%, but DOM content loaded, which is a non-visual metric, was about the same. Render was at 65. So, but time to first byte was more relevant than speed perception and perceived speed. I mean, speed index and perceived speed index, which is the ones we were like looking at. So that led to a few questions. Mostly, can metrics be improved? And whether the jitter was an issue and everything else. So this is an equation we came up with, and I'm not going to go through it. I'm just going to show you this, right? Why are we measuring something that goes beyond load time if people are not waiting to visually complete? So we basically have all the speed index and perceptual speed index going on, right? We have this equation. This is going from 0 from the time we make the request all the way through to visually complete. But people have made their decision here, and we're still measuring something. So let's get rid of all that extra time with speed index and say, let's stop PSI and SI at load time. And then there was a 79 to 81% correlation. So speed index and perceived speed index are actually really good metrics if you don't go to visually complete, if you actually go to when a person thinks the page is loaded. But the thing is, we still don't know when a person thinks the page is loaded. So visual metrics will perform better than non-visual metrics if you measure the visual metric to a more logical point. So hypothesis 2 was that no single metric can explain human choices with 90% accuracy. And as we saw, even with that metric, we got to 80%, but not 90%, so that was true. This was our original. We came up with the highest was 65%. When we went to page load time, it went up to 80% or 81%, but not 90%. But then we thought, what if there is a combination of metrics? So when we did to time to click, which was an estimate, because we didn't actually remember that little dot that you saw? We're actually studying that in number 2. But we made an estimate as to when time to click was. It actually brought it up to 84%. And then if you took speed index up to time to click and perceived speed index, or perceptual speed index up to time to click plus render, you got to, it says 87 to 90%. So we're just getting there. So the idea is we really need to do a second study because statistics lie and liars use statistics. So we found a number that's really highly correlated, but we didn't test that. That was not our hypothesis. So our hypothesis for the second round is that hypothesis true? Does this number correlate? Because we found a number that correlates, but we could have munged the numbers in any which way till we found what we were looking for. So now that we found what we're looking for, let's test that out. So we also thought people only looked at 2 videos and made their call. Is there additional information that we need to extract? And that is where the demographics come in. Sometimes I put a slide in and I can't remember why it's there. This would be one of them. And I'll just skip it. So if you're interested in the speed perception challenge, I really ask that you guys take it and promote it. But it is open source, and it is these are the links. And I'll update this because the links are actually incorrect. So in phase 2, we're studying the jitter, we're studying the demographics, and we're also studying the DOM content loaded because this is something that is an objective metric that I think is really bad. And what I've been seeing developers do lately with all these frameworks that they're putting in, creating single-page JavaScript applications where all of the JavaScript is loaded before anything is printed to the screen. And so it's going to have, like the page loads in 1 second. You're all like, yes, it loaded. But you don't see anything for a while longer. And then you can't interact with it for a while after that. Does that impact performance? I would say yes, because my logic tells me yes. So in the end, while I've covered all of this stuff and while we're looking at all this stuff, you still have to use common sense. And one of those is the more bytes you send to the user, the longer it's going to take the page to load. The heavier you are on JavaScript, the longer it's going to take to be parsed, executed, and usable. So always remember that user experience trumps developer experience at every turn. So use all the frameworks you want when you're prototyping, but if you're actually pushing something to production, get rid of everything you don't need. Minimize, follow all the web performance rules that there are. And this talk is not about those web performance rules, but if you want, I can give a talk on that too. That's my other talk. And that's what I want to share on measuring this objective. Does anyone have any questions?
Thank you so much. So please send questions in #Mozilla in IRC or #speaker-series. We'll take questions in the room to start. If you're in another office, please ping me or just go up to the mic. Be bold. We'll start in Mountain View.
Can I make one announcement before you actually start with your question? Which is I am organizing a performance conference called Perf Matters Conf. And our call for speakers is October 1st. That's when it's due. And so far, I have no Mozilla people who have applied to speak. And I hear you're working on performance, and I hear you're interested in this topic. So I highly encourage you to apply to speak. It's going to be in Redwood City, so it's between your 2 California offices. Could I have made it more convenient for you? I don't think so. So thank you. Let's go back to questions.
So for the side-by-side comparisons in that study you mentioned, how did you pick, or were the pairings random, or how did you pick?
The pairings were not random. The pairings actually had we made it so that the videos would look like that they were at the same time. So they either had some metrics that were very similar. So like we'd have 2 that would have very close, either visually complete or page load time. And that way we could measure apples to apples and see which ones. So we pulled 500, we pulled from, and I didn't actually do this, so Parvez, Clark Goa, and P-Day did this. I basically helped promote it and then said, okay, as a front-end engineer, this is what I assume, and help with hypotheses, but I'm not a machine learning expert, so they did all the great work, and they used machine learning to figure out which two to put together. So it wasn't like a human said, I like this one and I like that one. It was done with logic, more logic than I ever have. But it was pulled from the top 500 e-commerce sites, and then aligned so that the videos, all of them turned gray at the exact same time. So it wasn't like they could wait till one turned gray, say, oh, I know that this one's faster because one turned gray. So no, they were not, it was massaged so that they were valid comparisons.
Anybody else in the room? Other rooms? Questions? Oh, we have one question, I should say. The second study that you're doing,
yeah.
Do you know when it's going to start and how long it'll take for phase 2?
It started about 2 months ago, and it's going much slower than phase 1 because phase 1 had a lot of social media, like a lot of people were into it, and phase 2 is like, oh, we already did that. Phase 2 is also has way more pairs. We're studying way more things, so we need more numbers. So phase 1, we had more than we actually needed. I mean, like, we didn't need that many to say these numbers are really valid. Phase 2, we basically need the same numbers that we got in phase 1. And it's hard to get 5,444 people. And we could do a Mechanical Turk, but a Mechanical Turk is people who are being paid and they want to get through the process quickly. They don't want to actually think about what they're doing. So phase 2 does, let me just show you phase 2 again. I'll just continue on. So this was a mobile comparison, and phase 1 did not have a mobile comparison. So we were only doing desktop. I said right? Okay, so I can then hit next. And so here's another mobile comparison, and I'm just going to click left and hit next. Because if I was doing this on my own, that's what I would do. Oh, and you saw that button popped up? I'm going to file a bug because it should not have allowed me to click next. Did anyone know which one went faster? Oh, I have to click next, okay. So that button that you saw pop up, I think the right one was there faster. That button, let me wait till I get to another button. Sorry, it's taking a while, but I have to randomly wait for the button to appear. Right? Left. Okay, so this button right here, this measures how long it actually takes to click, because we did not measure that, so we had to assume what time to click was. But we need to know what a person's reaction time is. Because right now, I'm destroying the results, so I'm not going to finish this. Because I'm talking, so it's like, oh, it took 4.5 seconds for someone to decide that the right one, so I'm just going to kill this one. Those are things that we're studying in number 2. So we're going with mobile, whether there's a difference between mobile and desktop. How long it takes someone to actually click, we're measuring that, so that we can say perceived performance, like PSI to time to click, is an actual number. Because there's a delay between when you make that decision and when you click. So we can say, oh, we need to remove 450 milliseconds from this person because that's how long it took them each time to click the button. So when they clicked the right, they had already made the decision at 2 seconds, 450 milliseconds, even though they didn't click till 3 seconds, 200 milliseconds. So we can figure out exactly when the time to click of that video is for each individual person. So we have mobile. desktop, time to click. We're now comparing ones that have pop-ups with ones that don't have pop-ups. Unfortunately, all the previous ones, there was no comparison there weren't enough comparisons between ones without pop-ups because there were only 2 sites that didn't have pop-ups. That says something about e-commerce sites, but maybe pop-ups don't actually bother people. Like, that might be what we find out from this study. And I would be gobsmacked if that was I would be totally stunned because I absolutely hate pop-ups. But maybe it doesn't actually impact performance or perceived performance or performance at all. So that's what we're looking at. So it might be another 4 months before we get enough numbers. So promote it. The last time around, Pat Meenan actually put something on Web Page Test. So we got tons of people. But this way, the way we're doing it now, we're getting it much more randomly, so we might have a bigger age variance as well. And we need that age variance because my hypothesis is that if you're 18, you don't wait for anything to load because you grew up knowing exactly, like, this is what I want to do. And if you're 50 or older, you grew up without the web. And so you might be more likely to wait for something to actually load. I could be completely wrong and ageist.
Okay.
But we'll find out.
Okay, we definitely have questions.
Okay.
That was easy. So based on your current knowledge of the state of the art, what are the most important metrics you would put on a dashboard for an SPA you are creating today? I think
Single page app.
Yeah?
Okay.
And then there's a follow-up question. How would your answer change for a desktop web app, like a browser, or something Electron-based?
So there's some interesting stuff coming out of the Web Performance Group, which is looking at hero sections of the page. So the hero section of the page is basically the main area of the page that you want the person to interact with. So when we saw that staples took a really long time to load, the middle of the page loaded, it was some content in the upper right hand and the carousel. So what I would be interested in seeing is the speed index and the perceptual speed index of the main area of the page, which is where you want the user to focus, measuring that and testing the metrics on that and seeing if that actually, because it's a section of the page that the user is 99% likely to interact with. I mean, there's always your one-offs that really they're coming to your site to look at your code of conduct or something like that. So they're going below the fold, and that's not the person that I'm optimizing for. I'm optimizing for the person that wants to click like on Kayak or something, wants to click hotel flight, because it always comes with hotel first, because I think that's where they make their most money or something, because it's never flights, and I don't know anyone who uses it for anything other than flights. Does anyone use Kayak for anything other than flights? No, so why don't they put that button first? Because they're trying to sell something else. We should have a talk with them, actually, about this bad user experience, because they're putting their business in front before what the users actually want. So they should change their business plan, because I said so. So that's what you really want to measure, which is when you can actually click. When is that flights button clickable? Because to me, that's when the page is loaded. It's not if there's an image up here. And if everything looks like it loaded and I can't click on that flights button, then that, so if I was doing Kayak, I would measure when the flights button is clickable. And that to me would be the best metric for the page load of that page. So that's just an example, but what Google is calling it, and I think the Web Performance Group is calling it, is the load of the hero, which is not necessarily the hero image, but the hero section of the page, which is the goal of the page, and what the user's goal is, not the marketing team's goal.
You have more.
Okay.
Let's see. So this was voted up by a few people in IRC. So have you evaluated any open source real user measurement libraries? And if so, what are your thoughts and experiences and maybe favorites?
I have not, so that's a really quick answer to a very good question that I cannot answer.
Okay, we have more.
Okay. I love watching you talk into a box.
Yeah, the box is great. Can we use eye tracking experiments to evaluate perceived performance?
We totally could. That's not something that I was working on, but I think it's a good idea. And if you're trying to figure out what the hero is of your page, that is a good way to figure out what the hero is. It's what are the people looking at and what are they interacting with. Because if the eye is always going, like in the Z shape, then load this, 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 and that. So yeah, I think eye tracking would be a brilliant thing to do. But an eye tracking thing is hard to do a large-scale open source study on because that takes money and time. And
okay, you can roll the box.
Okay, so that's...
Hi. Question on performance in a lot of these cases isn't about the network. It's about just bad UX in the product itself.
Right.
So given the data that you're collected, could one just go through and categorize the bad UX that happens, like interstitials and slideshows still loading images while you already slide through, and all these really bad patterns that happen, to understand if it's not about how fast the page loads, but how slow it makes itself.
It actually showed both, because our hypothesis was that visual metrics are more important than the objective metrics that aren't visual. And time to first byte is definitely a network, right? Yeah. So it's not basically when you're looking at perceived performance, it really doesn't matter whether the server is to blame, because it's taking 2 seconds for the server. It does this, 20 years ago, it took 20 seconds for the server to do whatever. That's not an issue anymore. But if we were looking at that, 20 years ago, performance had to do with what was happening on the server. And then it had to do with, the last 10 years, basically, it's had to do with all the bytes that are coming down the wire. But now that our devices, the networks, at least the ones that we're using in the United States, are so fast, that's less of an issue. But it's still a huge issue around the world. So it's not like that's gone away. So time to first byte is still an important issue. If we had done this study in Siberia, I assume time to first byte would have been more correlated, because the time to first byte would have been maybe 45 seconds. I'm totally exaggerating. But if you have 45 seconds and then you have a really nice phone and it takes 1 second to load, that time to first byte is going to be more heavily correlated than whatever happens in the UX, right? Or in the UI. So what was your question again?
Just if one could look at a study and the videos recorded and understand how these artifacts basically throw people's perception off. Even though the page might load fast and is ready, it's still loading images and trying to animate them and doing all these things to make it look slower than it actually is.
And so that's what Speed Perception 2 is looking at. Speed Perception 1, we didn't look at that, and we couldn't look at it because all of these pages had jitter and artifacts. All of them did. But if you load a news site, it's not going to have all those, well, most of them. A lot of them will not have all that jitter. Like Forbes will black out your page and tell you can't load because you have ad blockers on. And so it loaded fast, but it's a terrible user experience. But most, if you're logged into the Washington Post, it loads up and there's no added pop-ups, there's no jitter. So now we are comparing ones with jitter to ones without jitter to see, because pop-ups annoy people. So it's bad UX, whether it's fast or not. But does it make the page load appear slower? That's what we're looking at right now.
Yeah. Having exact numbers in a study on that would actually help people to make a decision to not do these kind of things.
Yes.
Just giving more education out there that it's really bad.
Yeah, we already know it's really bad as developers. We push back with on the marketing teams. Who here is a front-end developer that has said no to their marketing team? Yeah. Okay. I know what I can do. Who here is a web developer that has never said no to their marketing team? And then I don't see any hands come up. We know it's bad user experience, but we don't know whether it changes the perception of performance. So performance is basically how long a page takes to load. It's not the time to interactive on the interactive button. Like, let's go back to Kayak, and Kayak doesn't do this, but let's say Kayak just said, sign up for our newsletter before you could click on that flight button. Well, that flight button is still the thing that we should be measuring in terms of user experience, but it's not really page load time. And by page load time, I don't mean that metric. I mean how long it actually seems like, the perception of how long it took to load. So maybe we should come up with like a usable and happy metric. Hua, happy, usable.
We're getting near
Okay.
winding down, but we still can take a few questions. These tie in directly to Firefox. So as a front-end developer, one would assume that you'd prefer browsers to just, quote, render everything fast. But obviously, are there areas that you think browsers should pay more attention to or prioritize? And then related to that is any insights tied to Firefox and how we can apply this would be great.
I mean, it would make sense to load stuff above the fold first because that's what people see, but you already know that. It would also make sense to figure out what JavaScript is required for above the fold and for the interactions for above the fold. Like there's the isometric, which I think is just a fancy name for half on server and half on in the browser. Developers really need to do this, and I don't know if the browser can do it, but it would be awesome if the browser could do it, which is just figure out what the what JavaScript is required and only load that. And the company I used to work for, InStartLogic, that's actually what they do. They put a snippet on your site, and then they figure out what JavaScript gets executed by human interaction, and then they load with the first load just the JavaScript that's needed and stream in all the JavaScript. Like, if you're doing a single page app, what happens, a lot of people do single page apps, and they load everything they need, from the first page login form to the code of conduct, or to the terms of service, to how to help pages, to their career pages. 99.9% of the people going to these websites are not going to your career page on the first time they ever visit your site. Why are you loading all that data and all the JSON text for that? I don't know. So basically automating the idea of the isomorphic website, which is only what you need on first load. So InStartLogic as a service kind of does that. I don't know if the browser can do that and then put my company out of business, and that would be terrible. But I don't work there anymore, so but I do have stock options. So don't do that. Basically, my goal as a web developer or as a speaker at these things is to talk to web developers and teach them how to do things correctly, so they don't need the browser to correct it for them, and they don't need services like InStartLogic to automate it for them. And I think that what's happening is with resume-driven development and with, it's basically, my goal is a back to basics. And I don't know if the back to basics is dead. I hope not. But when people don't know what a name attribute on a radio button does, and yet they achieve the level of senior front-end developer, I'm kind of like, what do you need to know to be a senior front-end developer? You really need to understand, because there might be all these processes, and we might never have to hand code again, but the browser is still rendering HTML and CSS in the end. Like, all that JavaScript creates DOM nodes. And so we need to understand what those DOM nodes are doing. So that's why I speak, is to teach people what your input element is actually doing in the background. Like, why use an input instead of a div that looks like an input? Just use HTML. It's there. It's accessible. When we use frameworks and rewrite everything, we lose accessibility. and we lose performance.
Great. I think we have one more question. I just tried speed perception, and I'm concerned that just watching videos and deciding which one is faster isn't the same as actually using the website. Is there a risk that this would bias users, participants in the study towards first paint?
So it's not, we're not testing the usability. We're actually just testing what the perceived performance is of page load. And by page load, I don't mean the metric. I mean what the user perceives as a page load. So there could be risks, but it's still going to tell us whether that module is annoying or not. We're not trying to find out when the first page is usable. We know, like that metric of time to, like the interactivity, like if your page is not interactive, then it's not interactive and that's bad, but that's not what we're looking at. We're not looking at time to interactive. That's more of a UX study. This is totally just looking at all of these sites are focusing on, or all these companies are focusing, correctly so, on getting that page loaded onto the user screen. Then you also have to figure out how to make it work the second, immediately when it's loaded. That's a different concern, and that's also what people should be focusing on. But this study is focusing on all those, like basically every company is focusing on getting that page to render as fast as possible, or they should be, and that's the part that this study was focusing on, not the time to interactive, or good usability, or whether that flights button is clickable. Because that flights button on Kayak needs to be clickable, and that's what that company needs to focus on, but every company needs to focus on something different that's relative to their own site, and that's, we can't study everything. So this study was purely about page load.
Got it. Okay. If there's nothing else in the room, I think that is a wrap. Thank you.
Thanks.
Cue the music. Insert rock and roll here.